Good morning, everyone. I hope you're having a good day and that everything is going well for you. I hope that you're staying safe and healthy and that you're able to keep up with your work on Google Classroom. Okay, so yesterday we talked about climate and weather and those two factors and how they're influenced by the sun. Today we're going to be talking about other factors that affect climate. Now, every climate and pretty much all the climates on every planet is affected by both the atmosphere and the relationship to the sun. Because, like, for example, Venus is much closer to the sun than Earth is, it's also a much hotter planet. The surface temperature of Venus is 887 degrees Fahrenheit, which is hot enough to melt lead. It also has an extreme greenhouse effect because it has a very, very dense atmosphere that traps more heat than it can release. And because of its distance from the sun, it captures a whole lot more heat. And, it's about 500 degrees hotter than it would be if it were not for this effect. There's also a lot of volcanic plains and stuff. So Venus is a planet that is definitely highly affected. Same thing can be said about Mars, which could theoretically sustain life and supposedly might have at one point. But the thing is that it is still further away from the sun, so the temperatures are colder there. The influence of latitude, though, on climate is part of the Earth-Sun's relationship. So latitude and climate are very important with each other. During the Earth's annual revolution around the sun's direct rays fall upon the planet in a regular pattern. This pattern can be correlated with bands or zones of latitude to describe climate regions. Within each latitude zone, the climate follows general patterns. So between the Tropic of Cancer and the Tropic of Capricorn is a zone known as the low latitudes. This zone includes the equator. Portions of the low latitudes receive the direct rays of the sun year-round. Places located in the low latitudes have warm to hot climates, and because of the latitudes that form its boundaries, this zone is called the tropics. Now, the Earth's polar areas are called the high latitudes. When either the northern or the southern hemisphere is tilted toward the sun, its polar area receives continuous but indirect sunlight. From about March 20th to about September 23rd, the polar area north of the Arctic Circle experiences continuous daylight or twilight. The polar area south of the Antarctic Circle experiences continuous daylight or twilight for the other 6 months of the year. So they alternate which one gets, all the daytime, all the nighttime. The most variable weather on Earth is found in the mid-latitudes between the Tropic of Cancer and the Arctic Circle in the northern hemisphere, and between the Tropic of Capricorn and the Antarctic Circle in the southern hemisphere. In summer, the mid-latitudes receive warm masses of air from the tropics. And in the winter, the cold masses of air will move from the mid-latitudes to the high latitudes. So depending upon location, things are constantly moving in, and this causes the mid-latitudes to have a generally temperate climate that can range from fairly hot to fairly cold, or maybe neither of the above, and more dramatic seasonal weather changes. So when we think of our different seasons, we're typically associating them with the temperate latitudes. Okay, and this is just an example here of your latitudes and the average, or whether they're locations. So remember, C and H are your middle latitudes here, or rather. Okay, then you got your equator right here through the middle. Your tropics are on either side, and these are your Arctic regions up here. Now, at all latitudes, elevation influences climate because of the relationship between the elevation of a place and its temperature. The Earth's atmosphere thins as altitude increases. So you've heard stories about how, mountain climbers have to, it's harder to breathe the higher up in a mountain. That's just because the air's thinner. Thinner air retains less heat. It gets colder. Now, as elevation increases, temperatures decrease by about 3.5 degrees Fahrenheit for every 1,000 feet. So, the higher up you get, the colder it gets real fast. This effect occurs at all latitudes. It doesn't matter where you're at. For example, in Ecuador, in Quito, which is nearly on the equator. However, it's so high in elevation at 9,000 feet, the average temperatures are about 32 degrees Fahrenheit cooler than the nearby lowlands. Now, this just gives you an idea of your like oxygen levels as well. You got to remember, like the air is thinner. So like here at sea level, we have 100% oxygen. If you were to go to Denver, Colorado, it would be different. Like it'd be a little bit cool, like it'd be a little bit thinner. And so if you ever like watch sports, you hear about how Denver, like athletes have a harder time in Denver because they have a harder time breathing. And then when you get up to, say, Mount Everest in Nepal, you're at 33% oxygen. Now, there are also the effects of wind and water on Earth and climate. With like any air moving across the Earth, like the face of the Earth, is called wind. So this is just movement of air. And these winds occur because the sun heats up the Earth's atmosphere and surface unevenly, with rising warm air creating areas of low pressure and falling cool air creating areas of high pressure. The cool air then flows in to replace the warm rising air. These movements over the Earth's surface cause winds, which distribute the sun's heat around the planet. Okay. Now, global winds that blow in fairly constant patterns are called prevailing winds. Now, the direction of the prevailing winds is determined by latitude and is affected by the Earth's movement. Okay? Because the Earth rotates to the east, the global winds are displaced clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Okay? And this is a phenomenon known as the Coriolis effect, which causes prevailing winds to blow diagonally rather than along strict north-south or east-west lines. So they're more like going more like southwest or northeast, if that makes sense. Now, winds are often named for the direction from which they blow, but they're sometimes given names from the early days of sailing. So, like, named for their ability to move trading ships through the region, the prevailing winds of the low latitudes are called the trade winds. Okay, so these are the winds that blow diagonally towards the equator. And then you have the westerlies, which are the prevailing winds in the mid-latitudes that blow diagonally west to east, from about or between about 30 degrees north, 60 degrees north, and 30 degrees south, 60 degrees south. Then you have the polar easterlies in the high latitudes, which blow diagonally east and push cold air towards the mid-latitudes. Okay, so here are some of your different groups here. So you have the doldrums where like there's very little wind going at all. You don't want to get caught there if you're a sailboat. Then you have the other winds that people would use to travel to different parts of the world using sailing. Now, at the equator, global winds are diverted north and south, which leads, as I said, a narrow, generally windless band called the doldrums. Two other narrow bands of calm air encircle the globe just north of the Tropic of Cancer and just south of the Tropic of Capricorn. In the days of wind-powered sailing ships, crews feared being stranded by these windless areas. With no moving air to lift the sails, they would be stranded for weeks in the hot, still weather. Meanwhile, their food supplies would dwindle, their perishable cargoes would be stuck, and they would just sit there. They'd probably lose a lot of money. It was just a really bad place to be. It often got so bad that in order to take advantage of even the smallest breeze, sailors would then toss stuff overboard, like livestock, like fruits, vegetables. Sometimes, if a member of the crew died, they'd toss them overboard as well. Okay. Now, the reason that these are given a nickname called the horse latitudes is because, they would literally chuck the horses overboard. So that's how it got its name. Then there are ocean currents, which, just as wind moving patterns, you have cold and warm streams of water, which are currents, move through the oceans. Ocean currents are caused by many of the same factors that cause wind, including the Earth's rotation, changes in air pressure, and differences in water temperature. The Coriolis effect works in this too, causing them to move in clockwise circles in the northern hemisphere and counterclockwise in the southern hemisphere. And as ocean currents circulate, cold water from the polar areas moves slowly toward the equator, warming as it moves through the tropics. This water forms the warm ocean currents, and this warm water then moves away from the equator, cooling to become a cold ocean current. Now, ocean currents affect climate in the coastal lands along which they flow, and cold ocean currents cool the lands they pass. Warm ocean currents bring warmer temperatures. So, for example, in the North Atlantic Drift, a warm water extension of the Gulf Stream, which flows near Western Europe. This current gives Western Europe a relatively mild climate in spite of the fact that it has a very high northern latitude. Okay. And then you also have the water cycle, which is when wind and water work together to affect, these wind and water work together to affect weather pretty much like through the water cycle, which driven by temperature, condensation creates precipitation, which is moisture falling to the earth in the form of rain, sleet, snow, hail. And a sudden cloudburst that cools a steamy summer day is an example of how precipitation both affects and is affected by temperature. Water vapor forms in the atmosphere from evaporated surface water. Colder temperatures cool the rising moist air. The vapor condenses into liquid droplets, forming clouds, and then later, the further cooling causes rain to fall, which helps lower the temperature. All right, here's just some of the different ocean currents and how they end up affecting or where they go through the climate zones. Okay. Now you've got a couple other things you need to be aware of. We've got El Nino. So there are reoccurring phenomena or events that affect climate. One of these, probably the most famous, is the El Nino phenomenon. El Nino is a periodic change in the pattern of ocean currents and water temperatures in the mid-Pacific region. Now, it does not occur every year, but its frequency appears to have increased in the latter half of the 1900s. This is somewhat attributed to climate change, though, again, not totally 100% sure on that. But in an El Nino year, the normally low atmospheric pressure over the Western Pacific rises, and the normally high pressure over the Eastern Pacific drops. This reversal causes the trade winds to diminish or even to reverse direction, and this change in wind pattern reverses the equatorial ocean currents, drawing warm water from near Indonesia east to Ecuador, where it spreads along the South America coast. Okay. So this just gives you kind of an idea, like a visual here. The changed air pressures that come from El Nino, though, result influence climates around the world in a kind of like a domino effect. Precipitation increases along the coasts of North and South America, warming winters, increasing flood risk. Hawaii experiences reduced winds like those in the doldrums, and also drier weather. Southeast Asia, Australia, drought and occasional massive forest fires are going to occur. Scientists are still not really sure what causes El Nino or why it appears to be occurring more frequently. It's kind of attributed to climate change, but nobody's really sure. But it can be very devastating in many areas as far as economic cost and human cost, because the weather patterns changing will affect trade. It'll create more catastrophic weather events like hurricanes and typhoons and monsoons or monsoon winds. So it can be very important. And then there's landforms and climate, which the surface features of the Earth, those are landforms, and these can be affected by climate as well. I mean, like how high off the ground, for example. Now, large bodies of water, for example, are slower to heat and cool than land. So, while land may have more drastic changes faster, large bodies of water typically do not. But as a result, water temperatures are more uniform and constant than land temperatures. And because they are slower to cool, they tend to be more constant. Coastal lands receive the benefit of this moderating influence, and they have less changeable weather than, say, inland areas. So if you live closer to the coast, like on a beach, your weather is going to stay typically the same. Whereas, the further inland you get, the more varied it will be. And this also is an effect that's say near the Great Lakes, for example. So anything that's along the Great Lakes, their weather tends to be a little bit more constant than fluid. Now, mountain ranges also influence precipitation and affect climate. Winds that blow over an ocean are pushed upward when they meet a mountain range. The rising air cools and releases most of its moisture in the form of precipitation on the windward side, so the side of the mountain facing the wind. Okay? After the precipitation is released, winds become warmer and drier as they descend on the opposite or leeward side of the mountain. The hot, dry air produces little precipitation in an effect known as the rain shadow effect. The rain shadow effect often causes dry areas and even deserts to develop on the leeward sides of mountain ranges. So basically, when all this stuff comes together, you start to see how weather patterns and all that will be affected by latitudes, by other factors, not just including the sun. So climate is not just it has a lot of factors that go into it. Okay, so that ends our lesson for today. If you have any questions, please email me. I hope to see y'all tomorrow, and I hope y'all have a great day. Thank you.